My name is Subhash Kak, and I'm a professor of electrical and computer engineering in Oklahoma State University. I work on AI and quantum computing, and I have thought a lot about this whole problem of what AI is going to do to society because it is a disruptive force. It's a disruptive force much more serious than what happened with industrial revolution, where brawn was replaced by mechanical devices, because in this disruption it's the mind, the human mind, that's being replaced by computers. And this is going to have a rippling effect in almost all sectors of society, certainly in teaching, for example, in education, because you don't have to have the old bricks and mortar campus. By using technology, you can transmit information to far corners of the world, and you probably just need a few professors in well-appointed studios to create the material, which can then be shared. So this changes the picture. And in other areas where human judgment comes in, for example, a lot of tasks require recognition of patterns, and machines can already do that very well as human beings. And in other tasks, such as transportation, which in a developed country like the US, according to one estimate, about 30 to 40% of the entire workforce is engaged in. If you had self-driving cars, clearly that would be devastating to the economic system unless the economy is able to adapt and create new jobs. And that's going to be one of the great challenges facing political leaders and thinkers as to how to do it, how to manage the system so that you don't think of easy solutions such as universal basic income, because that's going to lead to a dystopia. You cannot expect people to be happy if they are provided money and shelter, and all that they have time to spend on is watching movies and probably smoking some intoxicant or drinking some intoxicant. So this is really a big challenge. Now, in the short term, the challenge is how do you compete with other nations which are also creating AI apps? And I think personally, even though India has the most programmers of any large country of the world, we are operating much below our weight class. And the reason is we are teaching programming via English, while our competitors such as China, Japan, Korea, and even small countries like Hungary and Czechoslovakia and Finland teach programming through their own language. Programming is like mathematics, and there's no reason why our students have to spend many years learning English before they can start learning programming. So this is something that is a problem of the most urgent, which requires the most urgent attention, because right now only the 5 to 10% of Indians who are very fluent with English are on the same footing as our competitor nations. And the rest of the Indian population, 90 to 95%, has to climb that mountain, and the mountain of the English language. And once they have done that, they're already fallen behind, because their facility with the English language is not as well as with their mother tongue. So this is something that we need to do. Now, the question of consciousness, this is the other side of technology, because one of the drivers is as to whether machines will eventually become conscious, and if they are conscious, clearly that will change the whole world. And it's even possible, one of the most scary situations would be that if there were such machines, they'll do away with human beings because they won't have any use for us pesky, always unhappy creatures. But personally, I don't think that will happen. And computers will always fall short of achieving consciousness, even though they would be able to mimic humans in almost all cognitive tasks, certainly not in creative tasks. And the reason why this is something on which opinion is divided. There are many leading scientists, computer scientists, physicists, neuroscientists who believe that computers will actually become conscious. I don't think they will, because there is something of science that machines don't capture. Even the projected quantum computers will not capture, and that is the underlying quantum mechanical nature of reality. While quantum computers, even if they were to be built, and in my view, they will never be built because of noise, but even if they were to be built, all that they do is to mimic classical computation, only that these machines will do it a bit faster. So I think the machines will fall short. And in fact, there has been this long debate in the West, and there's been a group of physicists and computer scientists and neuroscientists and some philosophers of science, which had been put together on a project by DARPA. And we met several times in the US and in Europe. And after many week-long discussions, about half of us concluded that machines will become conscious, and these were the ones who were driven more by this whole idea of complexity, that consciousness is an emergent property which comes out of complexity, which many people subscribe to, while the other half, and I belong to this other half, believe that this will not happen because it's something more than complexity. It is the very nature of reality, where, as we know, even in quantum mechanics, there is a split between the observer and the observed. And it appears that consciousness is more than just emulation of certain logical processes, which is what a computer does. And therefore, conscious machines would not be attainable, but consciousness would still be a very important element of the thrust of science in many different areas, including physics, because physics doesn't capture the observer. And in classical physics or in quantum physics, the observer is always outside of the mathematical framework. Now, in recent decades, many attempts have been made, at least in quantum mechanics, to explain the observer also in terms of the equations of quantum mechanics. But the general consensus is that these efforts have failed, and the dominant paradigm of quantum mechanics interpretation remains the orthodox Copenhagen interpretation, in which the conscious observer and the observed world are like two sides of a coin. They are one or the other, and one cannot be reduced to the other. And this is very interestingly totally consistent with Indian views of consciousness, which go back to the Vedas itself, because the Vedas call themselves Atma Vidya, which means the science of consciousness. And according to the Vedas, there are two kinds of sciences. Sciences which can be described in terms of language, and these are called Apara Vidya. These are sciences related to things, while the science of consciousness or Atma Vidya is Para Vidya. It's not material. And so in this view, consciousness is the underlying ground of reality, and all of our knowledge also resides in consciousness. And so it will forever be forever be beyond the framework of any mathematical or abstract theory, because mathematics or abstractions are also about things, while consciousness is not a thing. It's the light which makes it possible for humans to make sense of the world. So there are lots of very, very interesting questions, and there are lots of opportunities and possibilities as well. And I will just refer to one of them. And this is the current crisis that physics is facing. And this is the crisis that physics, when studying the cosmos, cannot explain the speeds with which the galaxies and the stars are moving, because they're totally in contradiction to the understanding that either the Newtonian gravitation theory or general theory of relativity provide us. And because of this reason, physicists have postulated that 95% of the observed world is dark matter and dark energy, even though that there is not the slightest shred of experimental evidence in favor of this dark matter and dark energy. In fact, another 4.5% is supposed to be interstellar gases. So therefore, all of our physical theories are based on 0.5% of the observed universe, which itself should suggest to us that there is something wrong, because if they were indeed dark matter and dark energy, why have we not been able to observe it? Now, it's quite possible that a shift of perspective might help us go outside of the box and find new resolution to this problem. And this going out of the box may be viewing reality, physical reality, in a slightly different way, where we are able to provide the conscious observer a different perspective, a different seat, so to speak, in this framework. And so it's quite possible that if people were to connect back to the long tradition, and it's not a religious tradition which we may, or some people may see in a pejorative sense. This is the Shastras within the Indian framework, where Shastras represent scientific argumentation, which include yoga and tantra and so on, which do address this question of why is it that the conscious agent is able to influence physical reality. And one of the resolutions, which is a part of this tradition, is this so-called Drishti Srishti Vada, which says that by observation you can control a physical process, which was later on put into a mathematical framework by the Indian modern great physicist George Sudarshan, who was also a Vedantin, in a paper with his collaborator Misra in the 1970s, a paper titled The Quantum Zeno Effect, which shows how by observation alone you can control or steer a quantum state. And this is something which has been experimentally observed in various labs, and it's a very central finding of modern physics. And there are many others which many other such insights within the consciousness studies tradition of India, which we don't even know how to properly evaluate, because not too many people have looked at it, and not too many people have looked at it because, as we know, after India became free, India consciously decided to separate itself from its own scientific tradition which includes physics, such as the physics of Kanada in Vaisheshika Sutra, which Indian scientists prior to 1947 were conscious of. If you look at Vivekananda and his discussions with Nikola Tesla, where he told Tesla to look for a theory which would connect energy and mass, or if you look at Jagdish Chandra Bose, S.N. Bose, Meghnad Saha, even mathematician Harish Chandra, and many others before 47, they were in touch, or they had some sense of what Indian scientific tradition was. After 1947, India turned its back on its own tradition, and maybe the time has come to look at this tradition afresh, make it a part of Indian Indian education, certainly graduate courses, and possibly there should be a summary of it, which is taught also to high school students and to college students, which puts Indian students in touch with the history of Indian sciences. Because if something is not in open light, if you put it away in dark corners, then people make all kinds of errors about what it is, which is when people can make claims such as, or they can interpret metaphors as literal truth, which is what has happened sometimes. So rather than uh, keep it in dark corners, it should be brought under the glare of light. It should be made a part of critical thinking, which is what institutes of higher education, or which is what symposia at conferences should do. And I think that'll be good for everybody. That'll be good for India. It'll be good for world science. It'll also be good for India for another reason, because it'll provide self-confidence to Indian students so that they are able to approach these the problems of modern science with full faith in themselves. Because without Atma Vishwas, you cannot be Atmanirbhar.